Google what's inside the Howard campus and you'll get... Seriously, it's like the internet's best kept secret. No TikTok tours, no Instagram reels, just a bunch of fancy words like synchrotron and innovation cluster. But guess what? Today we will be going through the door to show you the labs, some of the experts, and yes, the actual particle accelerator. If you ever wondered what neutron source look like, well, this is your chance to know, because today I will be taking you on a tour through the Howard campus. What used to be a nuclear laboratory research post the Second World War to a place where scientists invent space technology and fight diseases. So if you want to learn how what we learn at UCL connects to the real world technology, this is your exclusive backstage pass. Let's find out. We are in ISIS neutrons and muons source, and I know you're thinking, so I'm going to break this name down to you. This stands for intense, slow, interacting source, neutrons and muons source, and this is where the magic happens. We have a super microscope that uses protons to study materials at atomic levels, and this is where electronics that are used in spacecrafts get tested.
Ways and bombard what we call targets. So the target is made by the tungsten material, which is this one. Okay, have a try. It's a really heavy one. Yeah. You mean the atomic number or something?
No, like this one.
I'd say it's like
Well, who do the gym? Who do a lot?
five kilos, maybe.
Yeah.
So small and yet heavy.
Yeah, it's very condensed material. So the neutron.
Okay, right now we are in front of a machine that is supposed to measure the level of radiation here to make that we are safe. For some reason, it doesn't seem to be working. Just what you want to hear before you enter a building where they do experiments related to radiation. Hopefully we're fine. Let's find out. So this is where they fire high energy protons to create neutron beams, which scientists use to study stuff at the atomic level. It's like X-rays but way more precise. And that screen is showing the synchrotron's proton beam current, and the higher this number is, the more accurate the experiment is. And these massive concrete blocks, these are to ensure the scientists are safe from radiation while also providing walkways to provide easy access.
Where the protons bombard the target and generate the neutrons. Some keys here.
Oh yeah.
So these are the interlock keys to make sure no people is left inside the chamber.
Very important.
Yeah.
What's it? Sorry, can you repeat again?
Yeah, these are the keys for the interlock that can ensure no people inside.
Hi everyone, this is Ahmad and this
I'm Theo.
here, and today we're going to show you what it's like to work in Harvard campus and work within the RAL. So could you tell us a little bit about what you do?
Yeah, so I'm a graduate spacecraft thermal engineer. So basically, in very, very simple terms, I make sure that instruments and satellites don't go too hot or too cold. And that goes through thermal analysis, so basically predicting temperatures on the spacecraft or the instruments, or thermal testing. So actually verifying, putting the spacecraft, the instrument, in the vacuum chamber, putting it through certain specific temperatures in vacuum, and just verifying what temperatures we achieve then.
That sounds very interesting. What would you say is your favorite thing about working here?
I think it's probably the amount of direct contact we have with actual space hardware. So, for example, I've been working on a mission called Solstice, and I've been directly involved in the thermal testing, and so I have not just done the simulation, I've also seen the hardware. It's actually tiny, much tinier than you would imagine. And then we've put it in the vacuum chamber. I've been into the full clean room suit, the full outfit, and then I just went into the clean room, observed how it went, and then after that just helped support the actual testing. So you get a lot of actual direct contact with hardware. You don't just see it from very much afar. So it's been very nice for me.
Wonderful. So for all the students who are watching this, what would your advice be for someone who wants to enter this field?
Yeah, so I think the most important thing is really to give, at least for me, it was to really give practical examples of why you like things. It's very simple to say, oh, I like space, I've always wanted to work in space, but it's most likely the case for most people that apply. I think the really important thing is to showcase why. So for example, for me, I read a lot of papers on space thermal design before when I was still at uni. And I know I mentioned in my application, for example, how I liked the thermal design of the Solar Orbiter satellite with its sun-facing shield. And those are examples to showcase how you really like what you want to do, and you know, it's very practical examples. And I think that was what helped me a lot, at least for me, getting to here.
Perfect. There you have it, folks. Theo, thank you so much for joining us. Wish you all the best.
Yeah.
Alright guys, so that was the end of the tour to the Harvard campus today. If you enjoyed it, please let me know and comment down below if you're a scientist at the Harvard campus, what is something that you would invent? Let me know down below. Thanks for watching.